So let's talk items. Items are at the forefront of many games, especially RPGs. But getting items right is not always an easy task. Now, what is an item? Well, an item really is just a collection of attributes that really define what that item is. So, for example, an item needs to be rendered on the screen. Maybe the item has some value. Maybe it can be sold. Maybe it can be picked up and added to your inventory. Maybe it's a stack of gold. It might be a potion. Probably has a name. And on with all these different attributes that define what that item is. And the way people often define their items is like so. Oh, I know, we'll add an armor, a weapon, a consumable class. And maybe those will inherit from a base class. Oh, I know, we'll call it the item class. Now, that item class would probably have some properties that are shared across all the different item types. So most likely your name and description fields would be candidates for that. But what happens when you want to extend these items further? What happens if you want to extend your armor into leather armor or into steel armor? And then you realize, well, actually, my weapon also could be steel. My weapon could also be wooden. And you start getting into these layers of inheritance where it just keeps kind of going down the tree. And I like to call that N inheritance, the letter N, where the number of layers often depends on the complexity of your game. And many people get into what I like to refer to as inheritance hell. Now, what if I told you there is a way, a better way to model this? What if we had a way to model these items as a single entity and let that entity be defined by its components? So let me show you an example. So let's say I have a game entity here and I give it a renderable component, a quantity, a descriptor, and a gold component. Now, you probably already guessed what this item is. This is gold. So let's do another example. What if I have another game entity that has a renderable component, a weapon component, a flammable component, and a valuable component, and a descriptor component? This is a sword with flames. So why I'm telling you this is to try and paint a picture of why I like to use a component-based design for not just items, but all entities in my games. And this makes it really easy for us to design any number of systems in the game, including UI development, because we're operating on things that are split into attributes that we can pull and use separately without needing to figure out how to build an inheritance chain to support the needs of our game. And with that in mind, let's go back over to our project and start creating some of these components. The first thing we're going to do, let's create a new folder. I'm going to call this ECS. ECS standing for Entity Component System. So this is going to be where many of our components will reside. So we'll create another folder for components. And we'll create a new file. And this new file is going to be renderable.ts. So what are the things we need to capture in this renderable component? Well, for one, we need to know what is the item image, what is the sprite that needs to be rendered on the screen? Because ultimately, when you're rendering an item in your inventory, it's obviously going to be different based off the item type. And so the first thing we're going to capture is what is the frame of the item, and a frame corresponds to the name of the file of the item that gets stored in the texture atlas. So some of these concepts I discussed again in the first video. So if that's unfamiliar to you, please go back and watch that video, but I will try to explain to the best of my ability along the way. So let's go ahead and define this component. So we will create class renderable extends component. And we are extending component from the XC library. So for now, we're going to give this an any type, and we're going to define one property on this class. And that property will be sprite. And so we need to define the actual type of the sprite. So let's do that. So we're going to define an interface for sprite. And this is where we're going to capture all of the fields that we need to actually render an item on the screen. So we're going to have a height, it's a number, a width, which is a number, texture, which is a string that corresponds to the texture atlas, and last but not least, frame, which is the name of the item image file. So it'll be like, for example, dagger.png or sword.png, whatever the names of your files are. And so let's assign a type for this. And then we'll need to just initialize this in the constructor. So the way that XC works is whenever a component is attached to an entity, it'll initialize each of the properties in the component schema to whatever the default value is. So whatever we put here in the constructor is really just to make the compiler happy. It's going to be overwritten anyways by whatever values you provide. And that will make a lot more sense once we get a little bit further into the video. Let's see here. So first, since we are extending a class, we got to call the super method. And then we'll do this.sprite. And we'll just define this kind of initialized to an empty object with some no-op properties, just to make the compiler happy. The second piece to declaring a component with XC is to define the schema for the object. And the reason you have to do this is so that XC knows how to initialize components to their default types whenever a component is attached to an entity. And so we're going to define sprite as a type.ref. And a ref, let's see, do we import that? A ref is essentially a referenced object. The other types available to you are number, JSON, string, Boolean, and array. So by doing ref, you're telling XC that you will be passing an object as the parameter for sprite. And because objects are passed by ref, it stores that as a reference type. And most likely it's just some performance optimizations XC can do under the hood. But that's how you define the schema, at least for this particular component. All right, so I've gone ahead and pulled in some of the components that we're going to be using for this video. Now, 3 of these components are what's called tag components. So that's going to be armor, that's going to be weapon, and that's going to be consumable. And what is a tag component? Well, in the XC world, a tag component is a component that lets you take advantage of performance optimizations that don't store data. And I totally just stole that from the description here in the tooltip in my Visual Studio window. Realistically, what that means is if you have a component that does not need to store any state, then you don't need to extend the base XC component class. And so in real life, if you were building out items that were usable in the game, you would probably not use a tag component for something like a consumable item. You would probably put some fields on here like number of uses or remaining uses. Same thing with armor, right? You'd most likely have some sort of defense value and weapons, some sort of attack value. So for the cases of building out the inventory system, this is a bit of a shortcut, but it works. It does what we needed to do. And so some of the other components that we're adding here, descriptor, a description and a name, super simple. Really all this one is doing is taking care of the item info that shows when you hover over an item, so the item tooltip. So you'll show a description, you'll show a name, maybe some other values we want to capture here, but this does what we needed to do. Picked up. Now, this one is really a utility to let us know where an item is in the inventory window. If you didn't store the slot index of the item, then you would have to always search all of the slots for where the item is. And so this is a quick way to let us index into the slots and quickly find the item to do whatever inventory operations we need to do. Quantity, again, very simple, storing the value. So this is the actual quantity of the item in your item stack. And a max value lets you define, what is the max value you allow for that particular item type. And so you'd have some logic then that would make sure whenever you're stacking or splitting items out that you don't exceed the max value. And maybe you have some validation involved in that. But this is a way to store that data. So entity ID, this is a way to store the unique identifier for your item. And this is really helpful if you are persisting your data at all, right? If you are saving the disk or saving to a database, you'll most likely have some unique identifier for that entity. And again, this is a way to capture that. And really the last one here, at least for the time being, is the valuable component, which is a way to associate a monetary value to your item. So this would be used, for example, if you're doing, some sort of shop system, right? Having a way to determine how much an item is worth. And maybe this value is calculated dynamically, but either way, having a component dedicated to storing that will be useful, and we're going to use it for our item tooltip information. So you might be wondering, what's next, right? How do I use these components? How do I get the data into the components? So these are good questions, and this is what we're going to tackle next. So first thing we're going to do, create a new folder called prefabs. And in here, we're going to create items.ts. And this is where we're going to put many of our item definitions or item presets. So I'm going to paste that in here. And let's take a look at what we have. So we've got an object. It's just a plain JavaScript object. And in that object, you should recognize now some of the fields in this data set. So we have predefined a handful of items like so. So I'm going to collapse these just so it's a little easier to see. And we'll go one by one and just kind of take a look at what each of these is doing. And so if you remember from the example in the beginning of the video, we defined a gold item as an entity with a renderable component, a descriptor, valuable, and quantity. And so this is saying that I want to represent a gold stack with one piece of gold. And what we want to be able to do is completely change how these items are used and how these items are represented just by changing the data. And so by the end of this, we'll be able to show things like, hey, well, what if I want to change the quantity of gold from the preset? And changing a 1 to a 30, you'll see represented in your inventory window as the gold changing from a value of 1 to a value of 30. So the next thing that we're going to do is we're going to take these item presets and turn them into components. And to do that, there's two files we have to create. Well, there's two files we got to create to get started. The first file, we're simply just going to build a new type called component types. And this is going to be used in order for us to turn the types of the components that we have into a dictionary that'll then be used to load in these item presets into components and then attach to a game entity. So copy this. If you've created additional components along the way, go ahead and throw those in here as well. Again, we'll probably add to these as the videos go on, as the series goes on, because there are some additional components we'll need to add. But let us now go ahead and create our GameEntity class. And so again, this is going to be the class that holds all of our components. So every item in our game is going to be a GameEntity. The player is also going to be a GameEntity. And all the other things that exist in the world will be a GameEntity. And so I've already created this offline, so I will paste it in here and we'll talk about what exactly this class is doing. So in Xe, you are more than welcome to use the default entity class. You don't necessarily have to create and extend that class, but they do offer the ability to extend the base entity class, and that gives you some flexibility. And one of the things that I've taken advantage of in this video and in this system is to add some getters for accessing components on the entity. And the reason I do that is so that I don't have to null check all of my components before I try to use them. And so I have getters for each of the components that we've created. So as you can see here, if you try and access a component and that component does not exist or has not been added to an entity, I'm actually throwing an exception. Let's fix this little space. And the reason I want to do that is because I want to make sure that you check to see if the entity actually has the component before you try to access it. And so when we create a new instance of a GameEntity, I could show you, for example, you'll have, as part of the API, the ability to check this dot has component. And if you wanted to check, does this entity have, obviously you wouldn't put this code in this getter, you'd have this in some other logic outside of the actual GameEntity itself. If I want to check that it has entity ID, this would return a Boolean. And so in my code, and you'll see as once we get to the actual logic of the inventory system, I'm going to check and make sure that all my entities actually have components before I try to access them. That way you're being more defensive and not having to null check necessarily each of the components every time. You've got a nice API for doing that. And so I found that this has just been helpful for me personally, and hopefully can extend that same functionality to you guys. So let's go back now to our main.ts file where we instantiate the phaser game. And here we're going to go and try to create an instance of each of the item presets that we've defined so far. So for example, I want to do something like this where I do const items equals get items, where this would return a list of item entities that we want to use in our game. So we don't currently have this function, so let's create it. So we'll go into our prefabs here, which we've created earlier. And in the items.ts file, I'm going to share some more code. So here's the function for get items. And all this is doing is it's going to iterate over all of the keys of the items and the item presets. So if you remember, that is all of the different item presets that we've created. And looking at this, I can see we might have a little issue. So what I really want to do is actually unnest the items from the item presets and just have them kind of flat on the object itself. So we'll do that, and then we should be able to fix this. There we go. Now we'll get all the keys. We'll iterate over all the keys. We'll index into the object to get the definition of the item. We'll create a new ID, and then we'll return kind of a raw version of our entity. So this is step one of getting the component data kind of configured and ready to get instantiated into a new entity. So let's import as well our UU ID v4 like so. And so if we go back to our main.ts, we can import this. And now we've got a collection of items, but it's still not yet mapped into an entity. So that's what we want to do. We want to get these mapped into their entities and instantiated so that we can use them, and ultimately we're going to wire them into our inventory system. So let's add another function here. And we can go in the same location as our initialize world function. We're going to call it initialize entity.ts. And let's bring this code in. Now, we've got a couple of IntelliSense errors, so we'll fix that as we go. The purpose of this function hopefully is self-explanatory based on the name, but it's going to take in a raw entity, which is what we just defined in our getItems function, and it's going to create an instance of an entity and then return that entity. So let's fix some of the compile errors here. So we'll import GameEntity. We'll import the component lookup, which we created earlier. This needs to be entity ID. We'll fix that. The other thing we're missing is we have not yet created our world. We have the function for it. So let's go ahead, go back to our main.ts, and let's create the world. So we'll do export const world equals initialize world. And this should give us an instance of the world that contains all of the entities in our game. So if you go back in here, not the get items, we'll go back into initialize entity. Now we can import the world into this file. Now, the only other thing that we're missing is this raw entity type or interface. So that one should be pretty easy to bring in here. So we'll drop this one in here. And our components, this should be component types. And this should be as, let's see, we did define the type of this, I think, in our other file here. Let me see if we can find it. So this should be as key of component types. Nice. So fixed all the compile errors. So you should notice some pretty similar patterns here. Again, all we're doing is iterating over the components. The first thing we do, we grab the component constructor from the component lookup or the component dictionary that we created earlier on in this video. Assuming we have that component, we want to add that component to the entity. And so this is utilizing Xe's API to do so. So Xe actually handles all of the component lifecycle methods that you would expect. So we give it an instance of the component we want to create, and then we give it the data. And so raw entity in this case would be whatever is returned from our getItems function. So as sort of a shortcut, instead of returning a raw entity here, I think I'm going to change this so that it returns actual game entities. So the way that we could do that is, let's move some of this code around, and we're going to say const raw entity equals this plain object. And then what we're going to do is we're going to create, we're going to return initialize entity, and we're going to pass in raw entity. And so this will give us a nice collection of game entities that we can now reference in our game. So let's run this thing and see if we can take a look at the game entities we're creating. So I've already got my dev server running. So let's navigate to, looks like we got a couple tabs open here, but that's okay. Let's take a look, and looks like we've got an error here in the console, which I think I know what this is. Yeah, we need to fix the import for the initialize world function here. So let's go back over to that initialize world, and we need to fix the import for components. So fix that, make sure we're properly destructuring from the export of the components file. So if we save that, come back over to our dev tools. Now I can see no more console error, and we have hit a breakpoint that I've set here so we can capture the output of the getItems function, which is what we just added. Now, if we take a look at this first entity here, we can look at the components that were created. And so 1, 2, 3, 4, 5 different components we created for this particular item, which is our gold stack. And so if we look at descriptor, these are the parameters we provided it. If you remember, we created a JSON object that represented the definition for this item. So we've successfully taken that and turned it into an actual instance, right, of an entity with a descriptor component with an entity ID, quantity, renderable, and valuable. Now I can see right off the bat, we forgot to create the gold component, which would be a tag component that we would use to know that this is a piece of gold. That's something we can do in another video. I'm not going to worry about that right now. I did want to go back though and take a look at the original drawing that we did early on in this video. So we will minimize all of that fun stuff and let's take a look at what we discussed early on. So this game entity we said was a piece of gold. And so we've captured many of the components here. The two that are missing from the game entity we just created are the gold component and the picked up component. So picked up won't come into play until we actually have an inventory, which is what we're going to tackle in the next video. We're going to actually wire these items into the player's inventory and into the UI. And so that's going to be the fun part. I'm excited to get into that. But the picked up, remember, references where the item exists in your inventory. So it makes sense that we don't have this one yet. The other one that's missing, which most likely is just an oversight, so we can go ahead and add it here, is the valuable component. So remember, valuable assigns some intrinsic value to the item. Now, if you have a shop system, that's where this would be used. Ultimately, if you had a trading system, that's where this would be used. And you take your valuable, you take your quantity, you multiply them together, and that gives you the final value of the item. So in the case of the gold, if you have a stack of 30, it's obviously worth 30 gold, but maybe you have different types of gold pieces, right, that you would assign a value of 2 to. And in that case, you'd have 60 gold. So hopefully you guys can do math. Makes a lot of sense. So that's probably going to do it for this video. Again, the next video is going to be where the magic happens, right? We're going to take all of this fun stuff we've just created and actually get the full prototype working. So I'm excited to show that to you. Thanks for sticking around, and I'll see you next time.